See Standard 12th Maths Chapter 6 XI 6.7 Applications of Vector Algebra. Sum number 5. Find the parametric form of vector equation and Cartesian equation of the plane containing the line vector r is equal to I minus j plus 3k plus t into 2i minus j plus 4k and perpendicular to the plane vector r dot I plus 2j plus vector k is equal to 8. So I am going to find the equation of the plane. It contains the line here. So where this is the vector form of a line. Here this is vector A, point coordinates of the point, and this is the parallel vector of a line, and this perpendicular to the plane. So this is the normal vector vector r dot n cap is equal to 8. So here, r, we are going to find the equation, parametric form of vector equation of a plane. So that contains the line means, so that contains the point also. This is the point, vector A is equal to vector I minus j plus 3k vector. And also it contains the parallel vector. So that is also in our plane as parallel vector. Vector B is equal to 2i minus j plus 4k. And again, our plane is perpendicular to this plane. So this is the plane equation. This plane contains the normal vector. This normal vector means normal vector is perpendicular to the plane. So the plane is perpendicular to a required plane, and also it is perpendicular to the normal vector. Therefore, this normal vector is parallel to our required plane. So let me take that as the parallel vector C. I plus 2j plus k. See, here we have the plane. This is a required plane. It contains the line. So it contains the point as well as the parallel vector. And also this is perpendicular to the plane. Some other plane. That plane equation is given here. So that plane contains the normal vector. Normal vector is perpendicular to this plane. So at the same time, this normal vector is parallel to our required plane. So just this is a rough diagram. You can understand the problem. So we have the point vector A and two parallel vectors. The question is, you have to find the parametric form. So vector r is equal to vector A plus s into vector B plus t into vector c. Substitute vector r is equal to vector I minus j plus 3 vector k. This is your vector A plus s into vector B 2i minus j plus 4k plus t into vector I plus 2j plus k vector. So this is the vector form of parametric form of vector equation. First question. Second question, you have to represent in the Cartesian form. Cartesian equation also we can say. So the point vector A, we take it as x1, y1, z1. The point is x1, y1, z1. That is 1, minus 1, 3. And the two parallel vector, vector B and vector C, coordinate as b1, b2, b3. Then again parallel vector c1, C2, C3. So the value is 2, minus 1, comma 4. Then this is 1, 2, 1. So the required form is determinant x minus x1, y minus y1, z minus z1, b1, b2, b3, c1, c2, c3 is equal to 0. This is the Cartesian representation of the equation of the plane. So substitute the values x1, y1, z1 as 1 minus 1, 3. So x minus 1, y minus 1, so y plus 1, z minus 3. B1, B2, B3, that is 2, minus 1, 4, C1, C2, C3, 1, 2, 1 is equal to, we'll solve this equation, x minus 1 into, leave off this row and column, minus 1, 4 2s are 8, minus 8, minus y plus 1 into, leave off this column and row, 1 2s are 2, minus 1 4s are 4, plus z minus 3 into 2 2s are 4, minus 1, so plus 1 is equal to 0. So minus 9 into x minus 1, minus 2, so that is plus 2, minus of minus here, plus 2 into y plus 1, then 4 plus 1, that is 5 into z minus 3 is equal to 0. So minus 9x plus 9 plus 2y plus 2 plus 5z minus 15 is equal to 0. So minus 9x plus 2y plus 5z, 9 plus 2, 11. 11 minus 15, that is minus 4 is equal to 0. This is the equation. You can represent this, the form, you can change the sign for all the term. 9x minus 2y minus 5z plus 4 is equal to 0. See, in your question, they ask you to find the parametric form and also non-parametric form and Cartesian form. We found the answer for parametric form and Cartesian form. Next is I am going to find non-parametric form. Non-parametric form. See, in the non-parametric form, we represent the equation in terms of dot product, vector B cross C is equal to 0. See, just directly we can write from the Cartesian form. So no need of doing the simplification B cross C and then take dot. Just I write that vector R dot, write the coefficients here, 9i minus 2j minus 5k. You take this 4 to the other side, minus 4. This is the answer. So whenever they ask you to find all the three, you first find parametric and Cartesian. From the Cartesian form, you can derive. Just write the formula and derive. Next question. See, I am going to do the 7th sum for you. Find the non-parametric form of vector equation and Cartesian equation of the plane. Vector R is equal to 6i minus j plus k plus s into minus i plus 2j plus k plus t into minus 5i minus 4j minus 5k. See, this is also the equation of a plane. This is in the parametric form. Here they represent the equation of a plane in the parametric form. But you have to find that in the non-parametric form and also in the Cartesian form. See, the parametric form of representing the equation of the plane is vector R is equal to vector A plus S into vector B plus T into vector C. So I collect that point vector A as 6i minus j plus k vector, and two parallel vectors. One is the term with s. So vector B minus I plus 2j plus k vector. Then vector, another parallel vector is vector C minus 5i minus 4j minus 5k. So this is a point, and these two are parallel vectors. Parallel vectors. So they are already given in the parametric form. Now we have to find the non-parametric form and also the Cartesian form. First let us do the Cartesian form. Cartesian form. So we take the coordinates of the point as 6 minus 1 k. Sorry, coefficient of k is 1 here. 1. So this is our x1, y1, z1. Then minus 1, 2, 1. So this is the coordinates of the parallel vector b2, b3. Then c vector minus 5, minus 4, minus 5. c1, c2, c3. So the determinant form is x minus x1, y minus y1, z minus z1, b1, b2, b3. c1, c2, c3 is equal to 0. Substitute the values. So x minus x1, y1, z1, 6 minus 1, 1. So x minus 6, y minus of minus 1 is plus 1, z minus 1, b1, b2, b3 minus 1, 2, 1. Minus 5, minus 4, minus 5 is equal to 0. You solve this. So x minus 6 into, leave off this row and column, minus 10, minus of minus 4 plus 4, minus y plus 1 into, leave off this row and column, 5, minus of minus 5 plus 5 plus z minus 1 plus 4 minus of minus 10, this is plus 10, is equal to 0. So x minus 6 minus 6 minus y plus 1 into 10 plus z minus 1 into 14 is equal to 0. So you simplify this, you will get the answer 3x plus 5y minus 7z minus 6 is equal to 0. This is the answer. See, in the non-parametric form, so you have the equation vector r minus vector a dot vector b cross c is equal to 0. So if you want to do the steps, see in the previous sum I asked you to write directly for you. So here just vector dot, write the coefficient 3i plus 5j minus 7k. You take the 6 to the other side so that it will becomes plus 6. So this is the non-parametric form of the vector equation. So you can write just as it is. This is the answer. Or if you want to do the steps, you find the b cross c first. Vector b cross vector c, that is equal to determinant I, J, K. So Vector B is here minus 1, 2, 1 and C is here minus 5, minus 4, minus 5. So you find the vector here. So I into minus 10 minus 4, that is plus 4, minus j into, leave off this column, so plus 5, minus of minus 5, that is plus 5, plus k into plus 4 minus 10, that is plus 10, is equal to, this is minus 6, so minus 6 vector I, 10 minus 10j plus 14k. So you substitute in the equation vector r minus vector a dot vector b cross c is equal to 0. So I substitute minus vector a as 6i minus j plus k dot minus 6i minus 10j plus 14k. So you can, if you want, you can stop in this way method steps itself. This is one answer, and this is the another form of representing the plane equation. So with that, this problem is over. Thank you.